Dissipation of energy of a simple pendulum. Aim: to study the dissipation of energy of a simple pendulum by plotting a graph of the square of amplitude against time. Apparatus: we require a spherical metal bob, a strong string of fine cotton, split cork pieces, a laboratory stand, a digital stopwatch, and a meter scale. Procedure: tie one end of the string to the bob and other end to the stand. Adjust the length of the string L from the point of suspension to the top of the bob with a meter scale so that the length of the simple pendulum is equal to 100 centimeters, which is approximately the length of a second pendulum. It has a period of 2 seconds. Hence, 10 oscillations take 20 seconds. Fix a centimeter scale horizontally to the edge of the table so that 0 on scale is in the line with suspension thread when the pendulum is in equilibrium position. Now, pull the bob to one side slowly and leave it. It will start oscillating in vertical plane parallel to the edge of the table. Let the amplitude be slightly greater than 10 centimeters. Start the stopwatch when the pendulum bob is at one extreme and amplitude is 10 centimeters. Note the amplitude A equal to 10 centimeters corresponding to t is equal to 0 second in the table. As the bob oscillates, the amplitude decreases with time. Note the amplitude A at t is equal to 20 seconds when the bob arrives at the same extreme end. Record T and A in the table. Record A at interval of 20 seconds. Calculate the square of amplitude in each case by using logarithmic table. Plot a graph of the square of amplitude A square against time t. Conclusion: energy of simple pendulum E is directly proportional to the square of the amplitude of its oscillatory motion. That is, E is directly proportional to A square. The graph of A square against t shows that A square decreases rapidly with t. Hence, energy of oscillations of the pendulum decreases with time. Precautions to be taken while performing activities are: 1. The initial amplitude should not be very small. 2. Measure the amplitude as accurately as possible.